Welcome back to the Advanced Microcontroller series. In the previous session, we discussed about microcontroller timers, which covers resolution, tick, quantum. In this session, let's discuss about scaling and modes. So, what is scaling? Delay the process of timer going to the ISR. So, delay the process of timer going to the ISR is nothing but scaling. There is two types, pre-scaling and post-scaling. Let's discuss about pre-scaling. So, after every instruction cycle, tick was incremented. In the pre-scaling, we having 1:1, 1:2, 1:4, then 1:8, like that, 1:16. Like that we having in the pre-scaling. So, what is 1:1? So, what will happen in the 1:1? What will happen in 1:2? So, after one instruction cycle, what will happen after one instruction cycle? One tick happen in case of 1:1. So, what is the duration for that? 200 nanosecond is the duration. So, after 256 tick, interrupt is generated. So, duration is 51.2 microsecond. This is about 1:1 scaling. So, what will happen in case of 1:2? So, in case of 1:2, so here what will happen? After two instruction cycle, one tick happen. So, the duration is 400 nanosecond. So, after 256 tick, interrupt is generated and the duration is 102.4 microsecond is the duration. So, this is what 1:2 scaling. So, what will happen in case of 1:4? So, here after 4 instruction cycle, one tick happen and the tick duration is 800 nanosecond. So, after 256 tick, interrupt is generated and the duration is 204.8 microsecond. This is what 1:4 scaling. So, similarly go with 1:8, 1:16. Same thing. For 1:4, 4 instruction cycle, one tick happen and this is the duration. After 256 tick, interrupt get generated and this is the duration. This is about the pre-scaling. So, what is post-scaling? So, what will happen in the post-scaling? Let's discuss about the post-scaling. So, after how many overflow an interrupt is generated? So, in the pre-scaling we having 1:1, 1:2 like that. Similarly, in the post-scaling also we having 1:1, 1:2, then 1:4, 1:8 like that. So, what will happen in case of 1:1? So, in 1:1, one overflow happen. In case of 1:1, one overflow happen and the duration is 51.2 microsecond. Similarly, in case of 1:2, what will happen in case of 1:2? 2 overflow happen, isn't it? So what is the duration for that? 102.4 microsecond is the duration. Similarly, you can go with 1:4, 1:8. So it is just delay the process of timer goes to the ISR. That is what, nothing but scaling. Let's discuss about modes. So what is modes? So after every instruction cycle, the timer is ticking. So if want to tick after an event, we can configure timer as a counter or PWM, pulse generator. So you can use timer to measure pulse width, PW measurement also. So this is what modes. And next is the example. So here you can see the requirement: 5 pulses of 8 microsecond, resolution 8-bit, quantum 1 microsecond, and general. In the PIC microcontroller, quantum is 200 nanosecond. This is different one, okay. So quantum is nothing but what? Tick duration. So here it is 1 microsecond. So what we need to do? We have to generate pulse, 5 pulse. So what is pulse? So pulse is nothing but what? Square wave with 50% duty cycle. So 50% on period and 50% off period. Okay, let me draw one pulse. So this is what? On period, and this is off period. So here what is the duration? What is the resolution? 8 bits, isn't it? So here for on period we having 4 microsecond, for off period we having 4 microsecond. So for off period we having 4 microsecond. So this is 4 microsecond, and even this also 4 microsecond. So what is the maximum value we can store in register? That is 255. So here quantum is how much? 1 microsecond. Quantum is 1 microsecond. So after how much duration interrupt getting generated? 256. So each tick takes 1 microsecond. So for 256 it takes 256 microsecond. Okay, let me consider one example. So here I am going to write one code. This code is written for toggling LED. So initially we need to write #define LED1. So here I am going to use port D. So I am going to write single LED na. So I am going to write RD0. Next is the main function. So inside the main function initially I am going to consider LED1 is equals to 1. So inside the while loop I am going to consider this line, LED1 equals to not of LED1. This line is written for toggling LED. And here I am going to write one for loop for int I equals to 5000. Then I value is decrementing. sorry, minus minus. This is the code. And one more thing, here I am going to write flat bracket. I forgot to write that one. So now connect this RD0 to the CRO. So initially consider RD0 equals to 1. So LED 1 equals to 1 initially. So here initially I am going to write LED 1 equals to 1. So that's why it is high. So next enter the main loop. So there toggling of LED. LED 1 equals to not of LED 1. So not of 1 is nothing but 0. Again certain duration what will happen? Toggling happens. So again certain duration toggling happens. So instead of LED I am assuming variable as clock pulse. So in place of LED I am going to write CP. Okay, let us write one more code. So here I am going to write CP. So when interrupt generated, control go to the ISR, isn't it? So here I am going to write ISR. So initially CP equals to 1, then what will happen? Timer starts, right? Then here it's toggling, then it is equals to 0. Initially CP equals to 1, then enter main function. Timer starts now. Timer starts counting 0, 1, 2 like that. So here I am going to write. So how timer starts counting? Initially 0, 1, 2. When it reaches 255, once it is 255, then roll over to 0. Now increment 256. Is it possible? No. So what will happen when it reaches 255? Then roll over to 0. Control come to the ISR. So when control comes to ISR, so here toggling happens. CP equals to 0. So how much is the on period and how much is the off period? So here initially in the pulse, so what will happen here? Initially it is 1, then toggling happens, that is equals to 0. Again toggling happens after certain minutes. So how much is the period? This is 256, isn't it? So this is 256 microsecond, and off period also 256 microsecond. but I want 4 microseconds. Can I use scaling to achieve this? So when do we actually use the concept of scaling? So if I use scaling, this time will increase, isn't it? But I want lesser time than that of 256 microseconds. So assume there is a bucket given to you and there is a tap to fill the bucket. It takes 10 minutes, okay? But I want to fill this within 5 minutes. So there are some conditions. You cannot have extra tap or you cannot add extra water pressure. So how do you think it is possible? You can take a half filled bucket instead of empty bucket, isn't it? So there is no condition that you can't take half filled bucket. So here same thing happens. You need to take the you need to preload the value. So in the ISR toggling happens. Now I have to make sure to reach the ISR in just 4 microseconds instead of 256 microseconds. So we need to preload the value to timer register. So what do you think we should to start with? So 252, is it possible? After 4 it reaches to 256, isn't it? So here I am going to write, so here after this I am going to write, so here I am going to write TMR equals to 252. TMR equals to 252. So how to do this? We need to write TMR equals to 252, right? So after that how it will starts counting 252, 253, 254, 255. So when it reaches 255, it rollover happens from 255 to 0. Control will go to the ISR. After 4 microseconds, what will happen? Control go to the ISR. There is one more. After 255, rollover happens to 0. Now again it starts counting 0, 1, 2. There is one more issue here. So how to solve this? Now again it taking 255 microseconds. Initially it takes 4 microseconds, isn't it? First time it took 4 microseconds, but next time it took 256 microseconds. But I need every time it should take 4 microseconds. So how to do this? So we need to write inside the ISR, right? So here we having ISR function now. So inside here we need to write. After the if condition, so here I am going to write TMR equals to 252. So now it works as expected. So it takes 4 microseconds, isn't it? So here also it takes 4 microseconds. For off period also it takes 4 microseconds. So yeah, here also it takes 4 microseconds. So how to find the value 252? So timer register value equals to 256 minus value is 4, right? So our aim is to get 4 microsecond. So minus this value from this 256, then you will get the value of 252. Let's write the code for toggle LED after 1 second. So here resolution is 8-bit, quantum is 200 nanosecond, time for interrupt is 51.2 microsecond. So how to find the time? So we having one formula, time is equals to tick into quantum into scale. This is the formula. Scale. So okay, let's write the code now to toggle the LED. So here we having code, isn't it? So here I'm just copy the code and rewrite again. So here I'm adding one more page. So here initially we considered LED 1 equals to 1, then turn on timer. So here I am not going to write this one. Instead of writing this, so here I am considering semicolon. So whenever interrupt occur, control goes to the ISR. So what will happen in the ISR? Toggling happens, isn't it? So here what will happen? ISR, if TMR IF equals to 1, then what will happen? LED toggles. So what will happen here? LED 1 is equals to naught of LED 1. LED toggling happens. So after that TMR IF is equals to 0. So this is the code. So now what? Okay, let me consider one timer register. So here I am going to write one timer register. So what will happen? So it starts counting 0, initially it is 0, then 1, then 2. So when it reaches maximum value 255, rollover happens from 255 to 0. So interrupt is generated. So after 51.2 microsecond, interrupt is generated. Control will go to the ISR. Then initially here we considered initially LED 1 is equals to 1. So 1. So when control go to the ISR, LED toggles. So 1 naught of 1 is how much? 0. So after certain duration again same thing happens, toggling, then 1. So same thing happens. So it takes 51.2 microsecond time, isn't it? So it is a very huge time. So I have go to the concept of scaling. Okay, let me write one more code now. So here I am going to write count equals to 0, then ISR. So I am having this, right? Yeah, ISR. Then if TMR IF equals to 1. So here what will happen when TMR IF equals to 1? So here I am going to write if plus count is equals to some value, here we need to consider. So what will happen when this condition is true? LED toggling. So LED 1 is equals to naught of LED 1, means LED toggling. So after that count equals to 0. Then what will happen? TMRIF equals to 0. Then close the flare bracket. So when interrupt occur, control go to the ISR, isn't it? So whenever interrupt occur, control will go to the ISR. So now here we need to find the value of this. So when count equals to 1, so count equals to 1. So here I am going to consider count equals to 1. So time equals to how much? 51.2 microsecond, isn't it? So no action takes place. Again interrupt occur, control go to the ISR. So count equals to 2 now. So now time, sorry, here I forgot to write time equals to, and same thing when count equals to 0, time equals to 102.4. When count equals to 2, time equals to 102.4 microsecond. Now no action takes place. Again same thing, when count equals to 3, how much time it take? It took 153.6 microsecond. So still no action. Again do same method. So when count equals to 20,000, time equals to 1.024 second. See, now you got approximately 1 second, isn't it? Approximately achieved 1 second. So how you got the value? You continuously tried, right? Count value. Count equals to 1, count equals to 2, count equals to 3. So instead of doing count equals to 1, count equals to 2, trial and error method, we can use some formula, isn't it? Instead of writing this one, you can use some formula. In the previous, here I have given time formula. So time equals to tick into quantum into scale into count. So now can we write count formula? By rearranging this, can we get count formula? So count equals to 1, sorry, not 1, time divided by tick into quantum into scale. Can I write like this? Count formula, can I write like this? Yeah, we can write like this. Instead of doing trial and error method, we can find the value of count using this formula. So here I am going to write this formula. So now time 1. So tick 256, quantum is 200 nanosecond, scale is 1. So let's find the value. So how much is the value? Open calculator. So time is how much? 1. So 256 tick, then quantum is 200 nanosecond. Nano means 10 to the power 9. And scale is 1. So how much is the answer? 19,531.25. So can we write like this? No, we can write 90,531. Can we write like this? But this is little less time, right? So here instead of 1 I am going to write 2. But how to get exact 1 second? So how to do? So can I change the value of time? No. But I can configure the value of tick. Yeah, obviously I can do. Quantum I can't change, but I can change this scaling type. So change the tick and scale and get integer value. So here you need to change the value of tick to get 20,000 of count value. So how to do? Okay, let's consider tick value as 250. Okay, 250 into 200 nanosecond. So here I am going to write 1 by 10 to the power 9, that is nothing but 10 to the power minus 9, that is nothing but nano. So here we got the value. So 1 by this value is nothing but how much? Something I did wrong. So here 1 by, not 1 into, yeah, we got some value, right? So 1 by, so time by this value is nothing but how much? 20,000. So now tick equals to 250. Sorry, not 250. 250. Tick equals to 250. So now we got the value. So here can I write 20,000? Yes. Can we write 20,000 here? So according to the calculation, after every 250 ticks interrupt gets generated, after 20,000 times you visit the ISR, we can toggle LED. So this is what disadvantage, isn't it? So here, so before that, one thing I wanted to tell you. So what should timer register loaded with? The timer register loaded with 6. So here in the main function I am going to write, so in the main function, so here I am going to write TMR equals to 6. And also after this TMR IF equals to 1, here also I am going to write TMR equals to 6. So this is how you are going to achieve a bigger time. But there is a small bug. Initially LED 1 equals to 1, timer loaded value equals to 6. Meanwhile software busy executing while loop. So here what will happen? So here it happened like this. So here 6, it starts counting 6, then 7, then 8. So when it reaches 255, rollovers to 0, like that it will happen. After 255, rollovers to 0, then interrupt generated, control go to the ISR. When control come to ISR, timer is overflowed to 0. So now here it making a jump from ISR to while loop, isn't it? It making a jump from ISR to while loop. So technically in C language we are calling contact switching. So control will go to the function definition. So control comes to ISR 20,000 times. It will come to the ISR. It is a disadvantage. When control jumps from while loop to ISR, it having jump instruction, and here time isn't stop counting, isn't it? So assume there is 2 jump instruction. Okay, there is 2 jump instruction. Assume we having 2 jump instruction. So when it comes here, if TMR IF equals to 1, so when it comes here, what will happen? It starts counting 0, then 1, then 2, then 3. Like that it starts counting. But after that it comes here, isn't it? TMR equals to 0. Now what will happen? Whatever timer had values, these values, it will lost, and it starts from 6, 7, 8 like that. So instead of TMR equals to 0, inside ISR you can write TMR equals to TMR plus 8. Can you write like this? TMR equals to TMR plus 8. Can you write like this? So here why TMR equals to TMR plus 8? Here we doing some addition using assignment operation, and 2 more instruction got added, hence it is TMR plus 8. So this is all about the timer. In the next session, we discuss about the configuration of timer. That's all about today's session. Thank you all.